Hello everyone, welcome to CoddingAdda with a new episode. I got many requests on learning path of GraphQL. So I have decided to make video on the learning path for a newcomer on GraphQL technology. And today we are here with that episode. So without further delay, let's get started. So before moving to the technical details of GraphQL, first we want to discuss what is GraphQL and why we will learn GraphQL. GraphQL solves three problems. One is it minimizes data fetching problem. Second, it maximizes front-end operation. And third, it has built-in support for document. Let's understand these 3 points thoroughly. Let's consider one feature of user post and comments. Like you can think of Facebook. So in Facebook, for a particular user, there are many posts, and each post can have comments. The response is like that. So let's consider me. I have many friends. Okay. So for each of my friend, I have many posted post. That means I have one friend, that is friend one. He has many posts in his wall, and each post has many comments. So if I have three friends, then in this array, friends array will be three object, and each object will contain one post array, and for each of this post object there will be many comments. Okay, so I have created REST APIs. Let's say I don't have any GraphQL services. I have a REST server. So if the front end want to display all this data, like in Facebook app or website, let's say there is a page where it will show you have this post from this friend, you have this post, this post, this post from this friends, and for each post it will show you have this comment in this post. So what I have to do in case of REST, I have one API which will give me all the friends, all of my friends, and in the response it will give me user ID of that friend. Then I have second API, post API, which will take user ID as input and it will give me all the post of that user. Then I have another API, comments, which will give me all the comments for a particular post ID. So in a REST world, I have to call three APIs, and this post API and comments API in loop to get all the data for all of my friends. This is very tedious for the front end guys. They have to call all those APIs in a loop and they have to wait for the data and they have to display. This is very difficult. And moreover, all those APIs will not be developed together. Backend guys will develop those APIs one by one and they will release. Then on each release of APIs, front-end guys needs to consume those APIs. So the development very low in this case. So that's why if we use GraphQL, then we don't need to call these three APIs. We will have only one GraphQL API and will give you all the data. So the backend guys will develop the feature and they will push all the data in the response of that single API. So front end guys will get all the data in the same API. The new tags will be available in the response. Let's say the comments service is not yet available in the backend. Only we have friends and posts. So until they will get friends and post ID and title. This will be blank. After developing comments, the backend service in GraphQL will be available in the tag will be available. So it will be very easy for front-end developers. They know I will get response here in this tag after released from backend. No loop, nothing. So it maximizes first front-end operation. Also, let's talk about the first point, minimizes data fetching problem. So in case of REST, we don't have luxury to choose what are the tags we want in the response. Backend will give you all the data they have, whether you need it or don't need it. In case of GraphQL, you can choose only give me friends and post. I don't need comments because I don't have any section. Why? To display comments. Okay, so it minimizes the data fetching problem. That means you will get only those data that you required. Okay, and GraphQL has built-in documentation. That means what are the things API requires in the input and what are the things API will give you in the response, that is built in documentation. You no need to write separate documentation for it. Be part of it automatically. So these are the benefits we have in case of GraphQL. So that's why many organizations are using GraphQL in their development. And now quite essential in case of microservice world. So in case of microservice world, we have many services and we can use GraphQL here very amazingly because we no need to touch the existing services that we have. Let's consider existing services. we can write separate GraphQL service that will fetch all the data from the REST services, and then it will manipulate the response and it will return to the consumer. Obviously, we'll see in detail in as we go in the lecture. So this is good fit in our microservice architecture. So now you know why we learned. Now the question is, as a newcomer who know REST, what will be the path to learn GraphQL? So without further delay, let's move to the next section. This is our learning roadmap. If you want to learn GraphQL, have two parts like learning of new technology. You have basic parts, schema, resolver, mutation, and data source. These four are in the basic part, and in the advanced part, you have schema stitch, auth, and gateway service. That's three things. These seven things are very much important to learn GraphQL. After learning these seven things, it will be very easy for you to learn any new concept on GraphQL. Now we'll start with schema. GraphQL has a concept of schema. Schema means here you will write all the types you have, all the operations your GraphQL server supports, all those things. We'll write here. You have particular format, write this. You need to follow that syntax and write all those things. And this will be your single contact documentation across teams. Across teams means the cross team, like front end, back end will follow the same documentation, same schema documentation. And this documentation is enough to generate built-in documentation for your API spec. We are taken here one example of user service, and the features we are providing in user services: fetching all users, fetching a particular user, and login of a user. That's three features. So fetching of all users and fetching a user is get operation. Get means in GraphQL will be query. It will be under query type. And login is a post operation. So it will be under mutation type. This user's query operation is taking get user it's returning get user response. So this is a type get user response, and those are the fields are there, right? Response. So it's returning array of users, array of get user response, and user query taking one user ID and return just get user response. Login will take email and password as an input, and it will return login response type. That is only token. This not mean mandatory. So it will always return token. In this case, in get user response, it will return always those fields as all are is mandatory. We'll talk later about this auth. Let's forget this auth and the auth directive and this enum. I think now you have a fair idea about schema. We will follow schema first approach. What is schema first approach? Schema first approach means we'll write schema by our own and will not be auto generated by any code. And according to schema, we'll write our resolvers, query handler, mutation handler, all those. This is called schema first approach. So schema will be created manually, then it will be shared across teams. And when all the teams are agreed on the schema, then backend guys will start development based on the schema. This is a truth for all team. And what is code first approach? Code first means backend will develop the code, write the code, and they will use some annotation. Okay, to auto generate the schema. So the schema will be auto generated by some framework. That is called code first approach. So we'll follow here schema first. You already know what is type, what is query in schema. So I'm going to then third point, type of a query, querying data from server. So this is the schema. Now front-end team needs to call this GraphQL API and they will send a query to the backend server that a backend server I need. This is the required input I'm giving you and I need this the response. This attribute in the response. So this has to follow a particular format and we'll see it later. What is the format for a client query to the backend GraphQL server? Resolver. To understand resolver, let's go to the code first. I have a sample service that is user service, and in this lecture we'll follow this repository and I'll share this repository in the description so that you can get the code. So we have the schema, the similar schema you have just seen. Now what is resolver? Resolver means we have this operations, query operations, user and users and login mutations. So we have to define some handler to serve this operation, right? When client will query for this or for login mutation, then some handler will be called and that handler will process the request and prepare for the response and send the response. This handler we call in GraphQL is resolver. So we should have user and users resolver and login resolver. Okay. So if you go to one resolver, that will be, I guess, here resolvers, users. Let's go to users. So you have users, you have user, and you have login. So it's a function, it's a async function, as you can see, and it's taking some arguments. Okay, so now we'll discuss what is the shape of a resolver. How many arguments can be here, and what is the meaning of those argument of a resolver. A resolver can have four arguments: parent, first argument, then args, context, and info. What is parent? Parent is the returned value of the resolver for the field's parent. This will be useful when dealing with resolvers. So this is required for resolver 10. I will come to this later point. Okay, this will be difficult for you to understand now. ARGS. So in this ARGS, we'll get all the inputs that client is going to send you. That means in user, you mention that I need user ID as an input. You will get this in second argument. That is, first we are not considering here unknown underscore, and we are interested about second, and in that second you will get user ID. Okay, so here you will get all the inputs that client is going to send you as per the schema. Okay, now what is third? There are four arguments. What is third? Third is context. This is the GraphQL context, and this is an object that is shared across all the resolvers. It will hold the state and it will be shared across all the resolvers. Okay, so we can persist something here and then we can retrieve it in the upcoming sub resolvers. Okay, we'll see details later on this argument. And fourth one is info, that contains some metadata about the operation. So we'll not deal with much with info. So we'll deal with parent, args, and context. We'll see parent and context after some time in details. Now you understood args will contains all the inputs that client is giving during query from the server. So this is the shape of a resolver. Now, how to implement a query resolver? So as we have already discussed, query resolver just a function that we are exporting, and it can take four arguments. From the second argument, you will get all the inputs. So based on the inputs, you will do all the operation. Here, what we are doing, we are fetching all the data from a DB, and then just we are returning all the response, and response type will be, as we discussed, get user response. Get user response. That's it. And how you'll tell this is your resolver for this operation? We have to register this resolver functions to the server. Now we'll come to the point how to create server. For server, we are using Apollo library. Apollo is a popular library for creating GraphQL servers. If I go to package.json, then you will see Apollo server. Okay. We are using Apollo server here to create our GraphQL server. So to do that, you should have one file schema.graphql. Okay, and that is under src. Now you should have one server.ts file. This is the starting point. Okay, so here what we are doing, we have one create handler. We are calling that function, so it will create your handler. We have the db url. Okay, if production, then we are connecting to production MongoDB instance, else our local MongoDB instance. Then what we are doing, we are creating our schema and we are giving this file here. So we'll come this point later, auth directives, that is this one. Okay, we'll come to this later. This is for authentication. This is an advanced part. We are creating the schema. Now we are creating server here, Apollo server. This is coming from Apollo server. Here you have to give the schema and couple of variables, then context. And the things you are returning from here, you will get as an third argument of resolver. Okay. And this will be shared across resolvers. So what we are doing here, we are parsing the token and getting the user, and then we are sharing user across all of our resolvers. Okay. Now, this is for playground. We'll see. And server.listen, we are sending the port number from env or 4000 and our server ready at this URL. So when you are creating Apollo server, then what you have to do? You have to remember that you are giving two things, two main things. One is schema and another is resolver of your handlers, of your operations. And resolver is coming from this resolver. We have this user.ts and we are getting all the handlers from this export, and the shape of your resolver will be in this format. In query type, we have two operations and in mutation we have one. So what you have to do, from resolver also you have to return in a particular format, query then mutation. So this is your root resolver, query and mutation. Inside that, we are returning our resolver. So this is for users resolver, this is for user resolver, and this is for login. So when a particular request from client for user will come, then it will go to this user handler. And from here, you'll get all the client's input and you will do all the things that you need to do in this function, and you will return the response as per the schema you have mentioned. And the response can be null because we haven't used not. If we use not here, that means you have to return user. Otherwise, GraphQL Apollo server will complain. So we are not using this expression. That means user can be null if the user ID is not valid. Now you have some idea what is resolver, what is the shape of a resolver, and how to implement a resolver with Apollo GraphQL server. Now I will move to the next point, that is mutation. So we have seen already query. Now we'll see mutation means post patch operation in case of post patch or put operation in case of REST, you can think, and query or get operations, or delete also in part of mutation. So for get, query, for post patch put delete, mutation. So we'll see what is mutation, adding a mutation to our server, and then testing, obviously all those things that we are discussing. So for mutation, obviously there will be a part in our schema that we are going to support login mutation. We are taking input, email and password, both are mandatory, and we are returning login response. That is also mandatory. And next, we need to write our resolver. So here in the second argument, we'll get client provided email and password. Then we'll do all the things to create a token, and we'll return token. Why we are returning only token? In our schema, we have mentioned that this type only contains token, and that is mandatory. So the same things you can see from here in your resolver. You have login, then all the things, it's generating the token and returning. Then in our resolver index.ts, we mentioned it, and it's already part of our schema. Okay. So this is the things you have to do for creating a new mutation resolver. Yeah, it's very easy, right? Okay, next. Now we will discuss about data sources. Till now, we have idea about resolvers, schema, all those things. Sometimes, based on the requirements, we need to fetch data from different sources. The sources can be REST API, can be database, can be any other things. So from resolver, we connect to different sources to get our data, then we return that data. In this example, our data source is a REST API. We are connecting to the REST API and we are getting all the tasks. And the base class we are using here, REST data source, that we are getting from Apollo library, Apollo data source. And this REST data source class gives us certain feature like all the common utility methods, like we are calling here this dot get, then we are passing URL and headers, and we are getting the response. Also, this class does caching, all those things. These are the benefits Apollo providing via REST data source. Similarly, they have other data source also like SQL data source. So how this works? From Apollo client means our front-end applications. It can be web or mobile applications that sending us the query to our server, that is Apollo server. From Apollo server, we have resolver. From resolver, we are connecting to the data sources and we are getting data back from the data sources. Then we are formatting that data and returning to the client. Now let's move to advanced section. So we have already covered the basic section. Now it's time to switch to the advanced sections. Now you have fair idea to understand the advanced topic. Now our discussion mode will be little different. What we will do? We will learn advanced concepts via a case study. Let's move to the case study. So I have given already a link. If you go to this link, then you can reach to this Medium post. So our requirement is creating a task management system where user can create tasks and they can put task in a bucket. Bucket can be like office bucket where all the office tasks will be there. Family bucket, all the family tasks will be there. And obviously there will be user who is going to register task. What we have to do? We have to design one high level design for this requirement. To do so, we analyze the requirement, then there are three features. One is bucket feature, one is task feature, another is user and authentication feature. And there is a relation of user, task, and bucket. So user can create task, multiple tasks, and a task will belong to a bucket, and a bucket will contain multiple tasks. One thing is given, the task service is already developed by the client and it is a legacy REST service. We have to use this service in our new design and we are going to use GraphQL here because we have mobile client also and web client also, and they have different interfaces in the UI. So we want to use here GraphQL so that the front end development will be first and they will only fetch the required amount of data from the server. As we discussed in the first section, why we will use GraphQL. So those points are satisfied here. That's why we are going to use GraphQL. Let's move to our solution. So this is our proposed high level design. We will have user service. This is the legacy task service and this is bucket service. We have desktop and mobile client. From here we will be one service gateway service here. So this will be developed in GraphQL. This gateway service will connect to user GraphQL service, bucket GraphQL service, and task legacy REST service. This gateway service will accumulate all the data from this sub services and prepare the response for the client. So client can only access this gateway service and these are not exposed outside. And we need some wrapper around this legacy REST service so that we can use it in our gateway GraphQL service. I'll come to that point. I think now you have idea. And we'll assume here you know how to develop a service, a GraphQL service here. As we already discussed in the basic section, how to develop one GraphQL service. And in the description of this video, I'll give the link of our GitHub code repo. You can refer to that repo to see all the codes. Let's move to, so we are assuming here we have already these three services. And in this section, we'll explore gateway service code. So this is our gateway service, my to-dos gateway GQL. The folder structure is similar. We have SRC folder. There we have all those sub folder. We have auth, data sources, directives. We don't know till now what is directives. We'll come to this point. And also executors and generated folder will come to here. And we know resolvers. We have types, means the TypeScript files, and some utilities files are there. And these are the schema, and this is our server data file. Okay. So first here we will see how we will create one wrapper around this legacy service so that it can be used like other GraphQL service in gateway service. So in the REST service, to do REST service, we have all the REST APIs to create tasks, fetch tasks. Now we will use this REST APIs as a REST data source here. So we'll create one GraphQL service around it. We will have one GraphQL service, we'll have one schema, and as per schema, we'll have the resolvers. From resolvers, we'll have data sources, and those data sources will connect to this REST data sources to fetch all the data, and then it will return. This will be our approach to create the wrapper around to do REST service. So for that, what we have, obviously we'll have one resolver. That is our resolver. So from this resolver, we are going to expose similar feature that we have in our REST service. What are the features that we have in our REST service? One is getting all to-dos and another is save to-do. So this will be, save to-do will be a create operation and to-dos will be a get operation. So that's why to-dos will be in GraphQL under query and save to-do will be under mutation. And the save to-do will take all the arguments that we were taking in our save to-do REST API request body. So similarly, we'll match here with the similar data type and name, title, description, assignee, priority, and user ID. So title is mandatory and user ID is mandatory. So that means this task is going to create by this user and all other attributes are optional. This can be provided and cannot be provided by the client. And it will always return task create response and it's mandatory as we are using this expression here. Okay. Similarly, we have created to do's query the REST API, to-dos get API was taking user ID as a path variable. Similarly, we are passing that as an argument here in this resolver, and it will return array of to do. That is already shown here, the type. Okay, so to do type has ID and user ID that is mandatory, and other fields are optional. Will come this auth directive later. Now you understood. So we should have some resolvers. Okay, if I go to resolver, then we should have some to do resolver, that is to do.ts. And in index.ts, similarly, we are returning query to do's resolver and mutation resolver. We are not doing anything. We can return save to do here. And from to do, we have this to do's resolver. In the second argument, we will get user ID, the user input, and using this, we are connecting to our data source. Okay, so data source is REST data source. That's why we have created a data source file, that is to do API, and that we are getting from this third argument. As we discussed in the shape of a resolver, in the third argument, we get all the things that is put in the context, and that is shared across all the resolvers. So we have saved from our context here data sources. Okay, so this is our context. Okay, so we have all the things in the context, and we have data sources also. In Apollo service creation sections, you can find one section data sources, and you can put all the data sources here. So you have put it to do API, and that will be accessible here, the data sources inside context. These data sources will be passed via context, and from data sources means this object will get access to this object. This is data source. That means from data source we will get to do API, data source dot to do API. Then we are calling all the functions that we have created in this data source. If I go to do API, that is our data source that we have created. As we have already seen in the example, to do API that extending to the REST data source. This is coming from Apollo data source. And we have function get task that is connecting to the list API and getting all the data. Okay, to do.get task. We are passing user ID. We are passing user ID here, and we are getting all the data. Okay, so and the data type is to do array. We are returning, and this is our resolver, and our schema tells us we will return to do array. So it matches with the return type, and it's fine. So we have created now the GraphQL wrapper around our REST API using data source concept. Now what we will do, we have ready now 3 GraphQL services: user service and task GraphQL service, the wrapper, and the bucket service. Now we'll see the code of gateway service. So gateway service, one job is to fetching all the data and then accumulate all the data, merge all the data, stitch all the data, and return to the client. We'll see how we are stitching all the data together. So why we need to stitch data. I'm giving you an example. So the client, when client will query the data, they will query in the format that, hey GraphQL server, give me this user's name, email address, and also all the tasks this user is created. So it will not say that give me the username and email only. It will say give me username, email, and all the tasks that is created. That means the email and name that will come from user service, and task will come from this task GraphQL service. You're understanding, right? That means, so this user name, email, all the user attributes and task attributes need to be stitched together before returning to the client. That job we'll do in this gateway service. That means gateway service need two schema. There's user service schema and also task GraphQL service schema. These two sub schema need to be passed along with gateway schema in our gateway server TS file that we'll see here. If we go to server TS and Apollo server creation, then we are passing gateway schema. Let's see what is there inside gateway schema. Here we are using stitch schema function. For that we are using GraphQL to-dos library at the rate GraphQL to-dos library and stitch feature. This is a popular GraphQL library, and from here we'll use many advanced feature. So here the stitch schema, we have to pass all the sub schema that we want to stitch. Here we want to stitch user schema. This will return you user schema and to-do schema. To-do schema that we have here only because we have created the to-do GraphQL wrapper in this gateway repository only. You can create another separate repo for these also. You can create separate repo and separate service to create this to-do GraphQL wrapper around to-do REST API. And that will be the good production practice. Here I have shown you just for your learning purpose. Okay. So, but in case of user service, we have separate GraphQL service for that. That I have already shown you in the basic section. This is my to-dos user GraphQL API. So from gateway, we'll connect to this my to-dos user GQL API. We'll connect here to fetch all the schemas that is stored in this sub GraphQL service. That is the schema. This schema, we no need to copy the schema and no need to put in the gateway service. This will be fetched automatically from this service. How we will do that? And we are doing this via this line. Okay, so we have user schema and this is fetching the user schema, and we need to pass on executor also, because when we'll fetch data, we'll directly connect to this subgraph to fetch all the data. Okay, so you can explore this fetch user schema function, how we are fetching. Here we are loading. Okay, again we are using load schema from GraphQL to-dos library. We are passing the URL of our my to-dos user GQL service. Via this load schema, we are loading all the schema, all the content of the schema. Now we have the schema, and we also need the executor. How you will get that executor? Again, we'll use function from GraphQL print function. It will give you the query. You can just use this code as is. and raw executor, then the similar URL, the same URL, the subgraph URL you have to pass here, then this query and the variables and the authorization header. This is important. Why you have to pass this authorization header? Because our subgraph, this my to do's user GQL API is protected. If it's not protected, then we no need to pass this authorization header. As it is protected, we need to pass this authorization header. If this is not protected, then we no need to pass authorization header. As it is protected, so the authorization header that we are getting from the client, we will see we need to pass here to authenticate our gateway schema, gateway service to our my to do's user GQL sub GraphQL service. So in this way, we are getting our user schema and we are getting to do schema, just loading the local schema, because the to do schema we have created in the same repo only. If it's the remote repo, another service, then we have to do the similar things like we have done for user service. So I have given you the two varieties here so that you can understand how to fetch local subgraph schema and how to fetch remote subgraph schema. For remote, you have to do this, or for local, just load the schema file. So we have the subgraph. If you have other subgraph also and you need to stitch, then we can put in this array other entries. Okay, so now we should have one schema for our this gateway GraphQL service also, and that is this one schema. Okay, and if you go to schema, then you will read, then we are reading just schema.graphql file, this one. This is our gateway GraphQL service schema. Okay, I'll explain detail what is there. So that means in gateway, when we are creating our server, then we have to pass one gateway schema. That gateway schema will contain all the sub schemas and the own schema. Then we have to pass the resolvers, as we have seen already in when we are creating the GraphQL user gateway service. Similarly, we have to pass the resolvers. That's all. Okay, so in the Apollo server, we have schema, then all other properties. You have to make introspection true to fetch all the subgraphs metadata. As we are fetching user subgraphs metadata, so in the user subgraph service, you have to make this flag to true. Similarly, we have context here. In the context, what we are doing, we'll explain later. The data source we have already seen, plugins, that is for rendering the GraphQL Apollo playground, from where we can test our Apollo server. So we can send query as if we are sending from our mobile and web client the query to the server, and we can see the results. Okay, till now it's fine. Okay, now what we will do, now we will explain the context we have here in our presentation. So we want to discuss the requirement that is already described. We want to discuss design, that is done. Teaching, that is done. Now we'll focus on the authentication. So in the story, we have told that we have to stitch all the information. And now we know how we are fetching all the subgraphs schema information here. But till now, we haven't seen how we are stitching the data? Because I just told you user need the information like user email, user name, along with all the to-dos that user. So how we are stitching, this user and uh, task GraphQL service data, that will first see. Now you have to come to this resolver portion in the schema. So we have already discussed sub schema, how we are fetching sub schema information, and this is our gateway schema. In the resolver sections, now we'll explore. Before that, we have to explore our gateway service schema, that is this one, schema.graphql. If I come here, just we are extending two type, get user response and to do type. What we are doing, get user response. So this type is not defined here in this service. This is coming as a metadata from our user type, user GraphQL service. Okay. Here, if anyone call this user query, then or get users query, then we are returning this one, only user related information. Now our client, what it demands, along with user information, you need to send us the task related information also, that is the to do this user has. For that reason, we need to add one attribute here, right? To do's attribute. We need to extend this type to add to do's attribute along with this. The similar things we are doing here. We are extending our type to add to do's. So now this contains all the user information along with task attributes also. Similarly, when client will call, give me details of this to do. So you have to send to do title, description, assignee, all those things that we have here. Along with that, they also demands which user is created this to do, and name, email address of that user. That's why what you have to do, you have to extend this in our gateway schema along with user information. I think now it's clear. So that's why here we are stitching the to do's information with user and user information with to do type. Okay, so all the stitching related type extension you have to do in your gateway schema. And also we have to write resolver how to fetch this additional data in our, how to fetch additional 2D information in our user type, and how to fetch additional user information in case our to do type. Now we will understand this concept. Now we will discuss how we are implementing resolver for this extended attribute. If I go to our resolver, then we can see we have this type, get user response, and we need to write this sub resolver. Why I'm calling this as sub resolver? Because we already have the main resolver in our sub service, user sub service. Now we need to only provide resolver for this to-dos attribute. So for this type, for this attribute, we are providing resolver here. Similarly, for to-do type, we are providing user sub resolver here. Let's explore first to-dos. So along with our user information that is here, we need to also provide all the to-dos that user has. So our primary key is ID here, because if you go to this type here, ID is our primary key. We will use this ID to fetch all the tasks, because if I go to our to-do query resolver, it will take user ID as a mandatory argument. So we are providing the resolver here, and we are returning all the to-dos for that user here. For that, we are using delegate to schema. Again, it will coming from GraphQL to-dos library. So what you have to do here, you have to provide the schema from where it will fetch the data, that is to-do schema. And what it will do, it will do to-dos query. So it will go to this to-do schema and it will do to-dos query to fetch all the to-dos. And what argument it's need, user ID, and that will get from user.id. So what it's need, user ID. All the arguments we are providing here. And from where we are getting user, we are getting user from this parent. In the shape of our resolver, we have one argument, the first argument, that was parent we discussed. So parent is the data from we are getting as a returned data from our main resolver. So from our main resolver, that is our user resolver, we are getting this get user response. And that means if I go to user resolver here in our index.ts and user resolver, from where we are returning the same things, all the user attributes, that means this object will be treated as parent here, and we can access all the attributes. Here we need only user.id, this id, that's we are referring here, this one, because we need this to fetch all the tasks. Okay, now you understood the parent. And the second argument is args that we are not using. Third is context that we are also passing here. And fourth, info, that argument also we are passing to delegate to schema function. And it will automatically call to the subgraph to-dos query, and it will fetch all the data and it will return. Now we'll understand another sub resolver, that is user sub resolver for to-do type. Here our base is to-do. If I go to to-do type, then to-do is already defined here only. We will get all those information. Along with that, we have to return user information. Okay, and we have already user attribute in the parent. We'll use that user ID to fetch all the to-dos. Okay, we will use this user ID to fetch all the user information. And from our user subgraph, we'll call this one and we'll pass to-do.user ID and we'll get the user as response. The same thing we'll do in our resolver in the gateway service. If we go there, okay, what we are doing, we are calling delegate to schema. In this case, as we are interested to fetch the user information, we need to go the user subgraph schema and we have to call user query, and there what we have to pass? We have to pass user query, and we have to pass user ID as input. We are passing user ID, and that we are getting from parent. As we are already discussed in to do, we already have user ID, and similarly we are passing context and information. Okay, in this way you can write sub resolvers. Okay, now you have fair idea how to write sub resolvers to fetch the extended attributes related data. So we already know by this discussions how to fetch subgraph schema, how to stitch them, and how to write subgraphs, how to write gateways on schema. Now we are only pending with discussion of authentication. Okay, let's go to there. In our server sections, we left this context discussion. Inside context, what we are doing? We are getting the request. Okay, from that request, what we are doing? From that request, this is basically our context. Okay, we are passing this here context. From there, we are fetching context.request.headers.authorization. We are fetching the authorization header. The header we are passing when the client is querying to the server. I'll show you when we'll test our APIs. And we are parsing that token in a standard way, and then we are getting the user, and we are returning that user from here, and it will be persisted in our context object as current user. So we are returning current user, then the request that we are getting, okay, as an argument here, the original context basically, then authorization header we are also passing here, and other custom headers that we are getting in the request. What are the custom header we are persisting in context? That is x header, x label, and authorization. This is our helper function to fetch this headers from the request headers, and it will be persisted in custom headers header object, because it is required later in our resolvers. You can persist all the information here that you require across all resolvers. So here, if the token is not exist, okay, the auth header is not exist, then we are returning null. And also if token is not exist, we are returning after BRR, we are passing the token. That means the second part of the string is token. If that is not exist, we are returning null. Also, if user is not exist, we are logging that error here. Okay. I think now you have all the idea how we are doing these things, fetching the user information. Now, the second part is how we are forcing the authentication. If I go to our schema, then we will understand how we are forcing authentication for our subgraph. So this function we are doing in our gateway. We are not forcing anything here. Okay. You're not forcing, just we are getting user, and current user will be null if the token is invalid, or we are not getting the correct user from the token. Okay, so now if I go to one resolver, our so basically we don't have resolver here other than the extended types resolver. So we have the main resolvers in our subgraphs. We have to go to our subgraph to see the authentication, how it's enabled. Now it's time to explore authentication implementation. As we can see in our to-do subgraph, to-dos query is protected, and this can be accessed only by admin users. What are the roles we are supporting? We are supporting admin, reviewer, user, and unknown role. That means for the guest user. So @auth is custom directive. We have created this directive here. Directive, then the name of our directive. The argument it accepts, that is role. And this can be defined on object or field definition. On object or field definition. Okay. So we are declaring custom auth directive here. And we are using that directive here to mention that our to-dos query is protected. Only admin role can access this query. Now, we need to implement this custom directive. For that, you need to go here in directive, auth directive. Here we have implemented this auth directive. Okay. And for that, we are using again the popular library GraphQL tools. So all the advanced feature we are using from this library. This library is very popular now, and it has all the popular features now, and it's stable. Simply we are passing the directive name that we are implementing, and here it can be defined on object, and it can be defined on type. Okay, there are two things we are mentioning. This is one object, and one key is this one type, and mapper kind, another is object field. Then you have to put the definition here. This is very easy implementation because the format will be similar. You can copy the format, just you have to change your custom implementation, nothing else. What we are doing here we are getting the auth directive. So again, we are using all the functions from GraphQL tools. Then we are passing our directive name. We are getting the directive name, and just if it is present, we are setting the name, nothing else. And here in object field, what you have to do? Again, you have to get the directive. And if it's present, then you have to give the implementation, because we are only interested on object field here in our schema. In our schema, we are only interested in object field, that is here. So what you have to do, if auth directive is present, then we are getting the argument that requires argument here. Okay, so it will be the same name as here, so you will get that value here. Then if it's present, then what you have to do? Then inside field config.resolve function, you have to get the user from the context, as we are already setting the user in the context. If you go to Apollo server, then you already know we are setting the user here. So we are getting that current user, and if it user.role not equals to this required, that means let's say the user who is accessing is having let's say reviewer role, but we require admin role. If it's not admin, then we are throwing the error here. Else we are resolving, means we are passing the chain to the next level, nothing else. So this is our custom implementation. We'll get all the required data from the context, then just you have to do your own validation. If it's not satisfied, then you have to throw error, else just you will resolve. I think now you got it, the implementation of custom directive. So you can implement your own directive, okay, and it can be auth, it can be any other custom directive. Just you have to give your custom implementation here. Then you have to do one more thing. When we are creating our server, when we are fetching our user schema, okay, as a sub schema, then in our fetch user schema, what you have to do? No, not in fetch schema, sorry. So when we are fetching our this to-do schema, we go to create local schema as, so for user we no need to do anything here, because user is, we are fetching user schema remotely from our user GraphQL service. As we are defining the wrapper for to-do REST APIs in this gateway only, that's why what we have to do, the implementation should be here only for the authentication, and for user authentication will be implemented in the subgraph only. So I'll recommend for to-dos wrapper, you move it to another repo and make an independent to-do subgraph. So here what we are doing in create local schema, this is your schema str, and then when you are creating one schema, then what you have to do? You have to get that auth directive. Okay, you have to get that auth directive. Okay, then this is your transformer. From this auth directive, you are taking this transformer, and this transformer will take the schema. Okay, and when you will get this auth directive, then you have to pass the directive name. We are passing the directive name auth, okay, because our schema name is directive name is auth. Then you are getting the transformer. Inside transformer, you are passing schema as argument. So this will give you the executable schema as a return type, GraphQL schema. So you are passing the schema here, and you will get final schema. Okay, as you have used custom directive, so you have to do this. And in make executable schema function, this will make an executable schema, and it will take two things. One is type definition, another thing is resolver, the to-do resolver that we have already seen. To-do resolver, this one to-do resolver, and one more thing is the schema file, the schema file as a string. It will take the schema file as string and the resolver. After taking this two argument, it will give one executable schema, and then you need to pass that schema in your directive transformer, and it will give you the final schema, parsed schema. And this you need to use in your sub schema. Okay? A similar implementation will be for user subgraph also. If you go there in the server, it taking the schema. Okay, and how we are getting the schema? Similar auth directive, Then we are passing the type definition, that is the string file of schema and the resolvers. Okay, so whenever you are using any custom directive, you have to do this. So now you have the idea how to implement authentication, right? So when user doing any operation, either query or mutation, if you have something like that, then automatically the execution will go here and it will validate that the user role having the required role or not. If not, then it will throw error, it will not proceed. And if it satisfies, it has the required role, then it will proceed to the resolver. That means in this case, to do resolver. So it will call your to do resolver in to do file. So your execution will come. Great. We have covered our advanced topics. So we mentioned that we will cover schema stitching and authentication. We have already covered that. Now it's time to revisit the gateway repo once and test our features. If I go to our gateway schema, so we have already explored data source, authentication, directive, okay, executor is for fetching the remote files, okay, that we have already discussed. Fetching the remote schema, in our case, it's user schema. And if you move to to a separate repo, then it will be for both user and to. And I will highly recommend that. So I will come to this generated section later. We have the resolver already. We have types. Okay, that is some common type. Transformer type and my to do server context. That's fine. Then we have utils, the common function we have defined it, that get current user from context we are using. Then some common files. That's fine. Then we have this our GraphQL schemas. Okay, this is for to and this is for GraphQL. If you move to a separate repo, so it will move to the separate repo. This and the resolvers. And this is our server.ts file. So one thing, if we go to package.json, then we have, when we are starting our server, then we have command start. What it's doing, it's building. Means we are writing our files in TS. So you have to build it. So this is the command npm run schema type and tsc. Okay, so it's doing the tsc typescript compilation, and before that we are using one more thing, that is schema type. So schema type is another script. What it will do, it will use another library, GraphQL CodeGen dash config CodeGen YML. So CodeGen YML will be one file here. Here we will mention your schema file path. In our case, this two schema file path. And what it will do, it will generate all the types from the schema to generated schema.ts file, generated schema.ts file here. So this is auto generated file. Okay. From schema, all the types will be generated. Get user response, mutation. So we are using this. Okay. In our, if I search here in our project. So this type we are using, right? This type we are using in our server.js and your server.ts. Okay. This one. So this type no need to create manually. So this will be auto generated by some tool. So that's why we are reducing our manual work. We are using that library. Okay, the CodeGen library, GraphQL CodeGen library. So we have to provide the path of our schema file and it will automatically create the TypeScript types. And then we can refer to that, to all those types in our resolver, return type or input type or there. Now, how we'll run our project? To run our project, we must start all our subgraphs. Here we have only one subgraph, that is user, and to do is already in gateway only. Now we'll run our dependent user subgraph. To do so, we have to go to package.json to see what is our starting command. It is npm run start. What it's doing is building, then it's running the server.js file. So npm run start. Okay, I forgot to mention one thing. This service has a dependency of MongoDB. So please run MongoDB before executing this command. Okay, so our user subgraph is running on 4000. Now I will go to our gateway service. Okay, so gateway has only dependency on user subgraph, and our to do wrapper subgraph is already present inside gateway only. So we no need to run separately it. Now I'll run npm run start in my gateway GraphQL service. So it will run the gateway GraphQL service, and it will fetch all the data from that 4000 port of user subgraph. Okay, now it's running 3000 port. Now I'll show you one interesting thing, how to test your APIs using Apollo GraphQL Playground. So you need to go to here and you need to execute URL studio.apollographql.com/sandbox/explorer. If you go here, you need to provide your URL. In my case, its gateway URL is 3000. Then you have to enter. You'll see a page like this. It has 3 sections. One is documentation. I promised you, I'll show you how documentation is auto-generated in GraphQL. It's one of the USP of GraphQL. It will show you all the mutation you have in your gateway. It has login and save to do. So it's coming from user and it's coming from to do's. Okay, so all the things are stitched together, and in query to do's and user. So these from user and this from to do's. Oh, so we have now understand our stitching is working. Okay, in the right hand side you will get the response. I'll come to it. Here you need to write your query and then press the execute button. And these are the section for variable. Okay, so you'll see like this in your case. Now I want to execute the login first to get the token. So if I click on there, all the things will be automatically come here. Now you'll see, okay, you have email and password null. So I have just copied. Okay, let me replace it. And what are the things you get in response? Okay, so that you haven't mentioned anything. So these are the fields present in this response. I want token. And if I execute, congratulations, you have successfully executed your login mutation and you are getting the result. Okay, now we will try to use one query. Okay, now if I go to query, let's say I want to execute user. So it has separate section in the query, then users. What we want in response, maybe all of this or one or two of this. These are the fields present in this response type. Let's say I only want email. If I execute this, I got error. Okay, this is unauthenticated error. Why? We go to our user and the schema users is protected. Okay, it has only access for admin role. So what we have to see, we have to provide some user with this role. That means we have to provide authentication token, because we go to implementation in the server, what we are doing in the server, we are taking the authorization header, and it will be in the format BRR, then space the token, it will pass the token and get the users. We have to provide one valid token here. To do that, new header, then authorization header we need, and it will be BRR mention space the token we have already copied. Okay, now if I execute this, yes, we are getting the data. Congratulations. One things you can notice here, we have 1, 2, 3, 4, 5, 6, 7, 8 fields. And if I go to our get user response in our user GraphQL service schema, we have get user response 1, 2, 4, 5, 6, 7. We have 7 here, but we have 8 here. Can you tell me why? Because this is URL of our gateway server, and we are getting to-dos also, as we have teached user and to-dos in our gateway. And in gateway, if we go to gateway schema, we have extended this with to-dos. That's where you are getting to-dos also. So in one call, you will get user information along with to-dos information. So it's very less headache for client. They will execute one query and they will get all the necessary information together. Okay, so they will get the exact data they only need. There will be no overflow or less flow of data. I hope you have enjoyed this learning journey. So I'll recommend you watch this video, and also I have the documentation here. If you go to in my Medium post, then you'll get all the documentation, and but I have provided together also. If you go to this link, design my to-dos project with GraphQL REST, I'll mention that link in the video descriptions. Then here we have 6 separate documentation for that. This is for the HLD that we already discussed. Then we have coding GraphQL service, authentication authorization, then coding the gateway service that we already discussed. 2 bonus things are there that is not present in the video, that is the web service and deployment of all services. And from there you'll get the link of second, from second you'll get the link of third. In this manner you'll get the whole journey. I think you have understood. And in each of this documentation you will get the link of the source code. Okay, that's very interesting. Now let's see what are the things pending. We have already completed advanced sections. Congratulations. Now we'll move to the certification sections. Sometimes our organization needs certifications of your skills. That's why you, after learning, you can do the certifications. Apollo provides us 2 certification. One is associate, another is professional. I have provided the link here. You can go to the link. Let me show you. If we go to that link, then it will open this page and you will get all the sections. So you have, let me go here. What you will do, you will get GraphQL tutorials. You have to go to the certifications, view certification details. So you have to first complete the tutorials before taking the exam. And if you go to details, these are the function you have to learn first, and they have also provided the documentation. Okay, all the documentation are there. You can go there, start the course, you can take the course, and all the questions are mentioned here. So you have to answer these questions to get the certifications, and it's embedded in the course only. So there is no separate exam after taking the course. You'll, it will be embedded here in the course only. So there is two tasks. Okay, and if you go to there is three tasks. You have to take the courses and you have to pass this question, and then you will get certification in the final. So you have to take two things separately, one for associate, another for professional. In associate, you have in associate you have these five things: basic, resolver, argument, mutation, and production, and the schema registry. Okay, and if we go to certification again, and in the professional, you have three things. Okay, federation. Federation means teaching all those things, and then how to convert monolith to microservice, GraphQL, and then federation in production, deployment in production. Okay, and after completing this, you will get the certification like yeah, I have mentioned already that in here you get the certification like, I think you have understood. So it will take the total time around for associate 5 to 6 hours, or max 8 hours, for professional max 10 hours. Okay, in the reference section I have already mentioned all the links. This is Medium link, this is the GitHub project source link, and other links also. This is the Apollo library links. So mainly we have used two library, one is Apollo and another is GraphQL tools. If you have any further questions, you can comment me in the video. I hope you have enjoyed and it will help you to become GraphQL professional developer. Thanks for the patience. We'll see you in the next lecture.